So now we're going to have expressions squared that we need to solve for. But the process is pretty much the same, just with a little bit extra work. So I'll first rewrite it. We have this x plus 5 squared minus 64 is 0. And we want to solve it for the squared term, since if we solve it for this, we can just take a square root of each side to cancel that square out. So, doing so, we'll add 64 on each side. So you get x plus 5 squared is 64. And from here, we'll just take a square root of each side. And so the square and the square root are going to cancel each other. So you just get x plus 5. I'm actually going to just drop the parentheses since we don't need it. But if you want, you can put them there and then drop them next step. And this will be equal to plus or minus the square root of 64, but the square root of 64 is 8. So x plus 5 is plus or minus 8. And so to solve for x, you're going to have to subtract 5 on each side. And in general, when you're adding or subtracting, I would recommend putting it in front of the plus or minus. A lot of times it doesn't matter, but it's a good habit to be into. So x is negative 5 plus or minus 8. And so now we can actually add 8 and subtract 8 to figure out what x is equal to. So minus 5 plus 8 would be positive 3, and minus 5 minus 8 would be minus 13. And from here, you want to check your work. So take 3, plug it back into the equation. 3 plus 5 is 8. 8 squared is 64, and when we subtract that, we do get back to 0. Likewise, when you put in minus 13 plus 5 would give you negative 8, and negative 8 times negative 8 is positive 64, which again will give you 0 when you subtract 64 from that. So we checked our work, and we can feel very confident that these are the right answers. So let's keep going. We're going to do 2 more of these, where you have this expression squared. So I'll rewrite it, x plus 7 squared minus 49 is 0. Let's solve it for the squared term. So add 49 to each side. So x plus 7 squared is 49. Now to cancel out the square, we will square root everything. And like I mentioned at the beginning part of the video, in the first video, that when you take a square root of a square, technically it's equal to the absolute value of whatever is underneath the square root. So the absolute value of x plus 7 is the square root of 49, which is 7. But in absolute value equations, there are going to be 2 different solutions. You can think about it. If you had, let's say, minus 14 in here, minus 14 plus 7 would be minus 7. But when you take the absolute value of that, you do get back to positive 7. And also 0 would work as well, since 0 plus 7 is 7, and the absolute value of a positive number doesn't change it. It stays positive. So that's technically how this works, but in practice, what we do is we separate it into those 2 equations, or we just say the square and the square root cancel, so you get x plus 7, and we put plus or minus to essentially acknowledge this step that we usually omit. So we'll have plus or minus 7. But the plus or minus is another way just to account for the fact that there are 2 solutions. So technically there is this subtle step in the middle, but in reality, we just write plus or minus 7 after taking the square root. So we want to subtract 7 on each side, so we can solve for x. So x is minus 7 plus or minus 7. And minus 7 plus 7 is 0. And minus 7 minus 7 is minus 14. Those were the 2 solutions that I mentioned when just looking at this absolute value equation. And from here, you just want to check your work. So if you plug in 0 up here, you get 7 squared, which is 49, and minus 49 would give you 0. Likewise, minus 14 plus 7 would be negative 7, and we're going to square that, which gives you positive 49, and you do get back to 0 when subtracting 49. So this is definitely the right answer because we were able to check it. So let's do one last problem. Solving for x, and we have this quadratic expression here. I'll just rewrite it. X plus 7 squared minus 11 is 0. We'll solve it for the squared term, so adding 11 to each side. So x plus 7 squared is 11. And we'll square root each side. So when we take the square root of a square, they cancel. And over here, we have the square root of 11. But we need to put that plus or minus. just to account for the fact that there are two solutions. And the square root of 11 is irrational, since 11 is a prime number. So if you plugged it into the calculator, you're going to get an infinitely long decimal expansion, though technically the calculator is going to round it at some point. But if you actually could write out the full decimal, it would go on infinitely without any recognizable pattern, just like other irrational numbers. So we need to solve for x, so we will subtract 7 on each side. And so you get x is minus 7 plus or minus root 11. Now this one might be a little bit trickier to check, but we can still do it. You do get two solutions here. You have minus 7 plus root 11 and minus 7 minus root 11. So I'll plug in the positive version to show you how to check this, and I encourage you to check the second solution on your own after pausing the video. So we're going to plug in for x this minus 7 plus root 11. So let me just write it. We are checking here. We have minus 7 plus root 11, and then plus 7, and we'll square it, and then minus 11 is 0. So the minus 7 and the positive 7 cancel, and you just get the square root of 11, and we're squaring that. And the square root and the square are going to cancel each other. And so you just get 11 here, and taking away 11 does get you back to 0. So these, or at least this one, is a valid solution. And when you check this one, you're going to end up with the same scenario, and that one will work as well. So the lesser one in this case is when you're subtracting that square root of 11. So you have minus 7 minus root 11. And over here you have minus 7 plus root 11, since this will be bigger than this one.